So we're going to take a look at deterministic, word I cannot say, solutions. The last video we were looking at the algorithm for the pivots, right? We're looking for a way to get good pivots for our median. Fuck, man. We're going to take a look at deterministic solutions. We saw in the last few videos, we've been looking at a algorithm to solve the median of a set of data. And we saw how if we were to randomly pick our pivot point, the x1 value, we could increase the time, the runtime, or not increase the runtime, but improve the runtime. So we want to actually see. We were just doing it randomly in that video, right? And we saw just by doing it randomly, we were saving time. But what happens if we were to actually put a bit of strategy into our pick? What if we wasted a bit of time just getting that pick right? Would we end up saving time? And we're actually going to see if that's going to be possible. So in the last video, we had a 50% chance of a good pivot, and a 50% chance of a bad pivot. So we had that, and that's worked pretty well. We increased our runtime, but can we do it even better? Okay, so this is going to be a trick, and this is going to be a long video and a messy video, so we are going to get crazy right now. So what if we were to not do it randomly and we were to have some strategy into it? So we're going to partition the set. So this is the set that we had, and we know that in a set we had, x1, x2, it's a bad 2 all the way to xn. We're going to partition this into groups, and these groups we're going to say they're going to be, let's go with n over 5. They're going to be n over 5 in size. So we are going to divide the groups into 5 units each, and we're going to have however many groups that is going to be. So we will have that many groups. So an example of this, we will have, I don't know, we'll call this, subgroup 1. And this is going to be, let's go x1, x2, x3, x4, x5. So we have the first 5 values. We'll have our subgroup 2, which is going to be x6, ... all the way to x10. I'm not going to waste everyone's time here. And then we'll have all these groups all the way until the end. We'll have our final group, which will be subgroup n over 5. And that will contain, whatever the last values are, right? So it might not necessarily have a complete set. So let's just say we went up to 30 or whatever. We'd have x30, x31, and let's say that was all we had left. You'd just have that in the last group. It's not, possibly, you're not always going to get the best possible division. You're not going to get multiples of 5. So things are not going to be perfect. But let's just go ahead, and we are going to use the values that we saw in that first video, right? So we had that set we saw in the earlier videos. If you don't remember it, it's not going to be important because I will just break it up here. So we will have 15 numbers there. So we have our subgroup 1, we'll have subgroup 2, and we'll have subgroup 3. Now we are going to write out those numbers. So essentially just x1 to x5 will be in this first row. So those first 5 numbers are 5, 15, 8, 3, and 7. In the next group here, it was 1, it was 9, it was 10, it was 6, and it was 17. And in the last group, it would be 12, it'd be 14, it would be 2, it would be 16, and it would be 19. Now we are going to find the medians of these groups because that is really easy. Like, look, there's only 5 numbers here. You will find these medians with your eyes closed. Well, you actually need them open because you still need to find them, but it's simple, right? So the median is going to be the middle value. So 3, 5, then the next value is going to be the median, 7. We have 1, 6, the next value will be the median, 9, and then we have 2, 12, and the next value is going to be the median, and that is going to be 14. So now we have the medians of all of these groups, and this is pretty simple. So it's an easy way to go about doing it. So now we found the initial medians, and this would have taken the time. Let's go ahead. Let's get something down here. We will go and change the color. We'll go with some nice light blue. So finding these medians, these are really small, remember. So finding the initial medians in time, it's going to be just big O of 1. And then to find them all, it's going to be is big O of n over 5, which is big O of n. Now we want to obviously find the median of the medians. What here is the median of the medians? We'll find that in a moment, but we can see obviously what it's going to be over here. Now, because it's a small problem, this is one thing that matters. Because it's a small problem, all these are pretty easy to find, right? Because we're not dividing these up into big groups. It will behave as constant time big O of 1. So this is why this is a nice little trick that we can do. It's going to be just so quick. It's just, it's effortless. They're just so small and it's so easy to find out. So we want to find the median of the median, right? So we want to find the median of the median. So we will have our subgroup of medians over here. And we can just, go ahead and order those. It was 7, it was 9, it was 14. Somebody who doesn't know anything about math will know the median here is obviously going to be 9. So this is going to be the median of the medians. And this is going to end up being our pivot. So by dividing our total input into groups of 5, finding the medians of all of those, and then finding the median of the median, that pivot is going to be better than the one that we get just by randomly picking. It's going to be better. It's going to be closer to what we want. Remember, we wanted a number that was between the 25th and 75th percentile. Well, this one is going to be in there, and it's going to be better. Well, most of the time, it's going to be in there. Now let's go ahead and draw some crazy picture, right? So let's say that we had, it's just going to be an absolute mess, but I want to use it just for visualization purposes. So bear with me, a massive bear with me over here. So let's say that we are going to have, let's go with, 10 of these, I guess. Or I don't know how many we want to do. This is not going to have enough room here. Not going to have enough room for what I want to do here. G1, 2, G3, yeah, the dot over here. Then we'll have the one that's going to be in the middle, Gn over 10. Just more dots here. I don't want to draw too many of these freaking things. This is all going to make sense for you in a moment. And this is the last one will be over here. This will be the G n over 5. So dot right there. Okay, so we have these sorted in 2 ways, right? These are going to be sorted. I need a bit of room on top here. These are going to be sorted downwards. So they are sorted this way. And they're also obviously going to be sorted this way. So this is going to be sorted in each direction. And we had groups of 5, we said. So let's go ahead, and these here will represent the values we have inside, right? This is just a bigger picture of drawing it. We will have all of our values inside, and you will understand the significance of this depiction in a moment. I promise you, you will understand what the purpose of this was. 0, 0, 0. These are not zeros. These are going to be values. They're just holding values. Okay, so we have this whole thing set up right over here. Now, what is going to be the median of the median, the 9 that we found, right? The 9 that we found is going to be this value right over here. The value in the middle of the middle is going to be the one that we found. Now, what do we know about this? It's sorted in 2 different ways, right? So all of these over here, all of these values that we see here that I'm circling, these are all the medians of these groups, okay? These are all the medians. They're the values that are in the middle because we had these sorted both ways, which means these are going to be the medians. And this means that these values on the left over here are going to be smaller than the median of the median, and the values on the right are going to be bigger than the median of the median, which would mean that here is going to get a lot of colors. I told you this is getting messy. It's going to mean that all of these values over here that I'm circling, all these values are smaller than the median of the median. And that would obviously mean that all of these values on this side, these values are bigger than the median of the median. I'll just go write m of m to save a little bit of time. This is going somewhere. I'm going to continue some of it in the next video, but I want to end off on this point over here. So what do we know about the left-hand side and the right-hand side right now, right? Just looking for some boundaries that we know, right? This is going to be the lower bounds of each one. So the amount of values inside of our left bin of values, right, the left side of the set that we made, is going to be greater than or equal to 3 times n over 10, right? We know this is going to be the n over 10, that was going to be the central value in the middle, and we know that the values including the medians of the groups lower, and then the other two values, because we have groups of 5, we saw when we circled those values, we will be circling values. We see how we're circling values over here, right? We're circling 3 values, 3 values, 3 values, 3 values, 3 values, and we're only focusing on one side of it. So in that case, we are looking from the from the midpoint to the start of the set that we've created over here. So in that case, that's why we have the n over 10. So that's a bound that we're going to have, and we're going to pick this off in the next video. I'll go ahead and write the other one for the right-hand side. This one is going to be greater than 3 multiplied by n over 10 as well. So we are going to have these lower bounds, right? We have these lower bounds, and should we go and combine them? We'll go and combine them right now. We'll go and combine them, and then we'll get into this, deep and again in the next video in case you're still a bit confused. So by combining these, we will have the size of the left-hand one is going to be less than or equal to n subtracted by the right-hand one, which is going to be less than or equal to 7 over 10, and the values that we are leaving out, right? So, and then obviously we can also do this, that we can also say, and we can do this, SL is less than or equal to n minus SR. I'm reversing these. Sorry, I got confused here. I was wondering, like, what the fuck am I doing here? I meant to reverse them, right? We can essentially reverse this, and it'd be the exact same thing. So we can say that SR is less than or equal to n subtracted by SL. There we go. This is what I meant to do. Yeah, I'm like looking at this. I'm like, what am I doing here? So there we go. So this, we can put them together, and we can see this over here. It's just a rearrangement of what we had before, combining them using these similar terms. And we're going to use all of this to determine the runtime in the next video. So this video has ran on for way too long, to the point where I'm getting confused and I have no idea what I'm even talking about over here. So this should all, this last part here is not going to be part of the algorithm. It's just analyzing it and understanding the runtime. So I hope you guys understood the things that we covered over here and what the goal of this is, right? We say that rather than randomly picking a pivot, I think there's a better way to do it, and that is with this deterministic solution, which is what we're working on, and we will continue in the next video. I'll see you there.